Hello and welcome back to this course of videos on MongoDB. Now in this video we'll be talking about database indexes. Now the reason that we put indexes on tables or collections within a database is basically to make it quicker to query the collections. Now an index on a database is very similar to an index on a book. Now, if we had a book and we wanted to find which page contains the word MongoDB, we wouldn't look through every single page in the book looking for the word MongoDB. What we would do is we would go to the index at the back, look at what page the word MongoDB is on, and then flick straight to that page. Now that's very, very similar to the way a database index works. If we put an index, and you put the index on a particular field within the collection or table, and once you've put that index on that field, then basically your database knows exactly where to go to find each value in the table. So rather than having to go through every document in the collection looking for that particular value that you're querying for, it will instead use its index just like you would when you're using your index for a book, and then flick straight to the document that you're looking for that contains the value that you're searching for, or values, and bring them back much quicker. So on small databases like we're seeing now, it doesn't make a huge amount of difference, but as your databases get much bigger, indexing will become extremely important. But I can still demonstrate the benefits of indexing right here. So first of all, this is our customers collection. It has 11 customer objects in here. Just to prove that, I can run the count method here, and you can see that it has a count of 11. Now the query that we're going to use to demonstrate our indexing is this one. So it's a simple query on the customers collection, and I am going to do a find and filter where age is greater than 70. Now you can see if I run this, I just get one single record, Jack Nicholson, and his age is 75. Now one other thing that you can do with Mongo to look at the performance of your queries is to chain a method on the end of your queries called explain. Now explain on its own will give you a certain amount of stats. You can see here we're actually going to add a single parameter to this called execution stats. Now when we run this, you can see it adds an extra key value pair here with a lot of key value pairs embedded within there, and one of the very important one is total docs examined. So what Mongo is telling us here is that it had to look at 11 documents in order to bring us back our result of Jack Nicholson, as you saw before. Now that's actually no coincidence that there's 11 documents in the whole collection. So MongoDB had to look through every single document in that collection before it could know that there was only one document or one customer in the collection with an age over 70. So similar to, like we said, that would be similar to looking through every single page in a book to get get the value that you're looking for, rather than flicking straight to it. So what we're going to do is we are going to add an index to the age column. And the way I'm going to do this is I will say db.customers again, and then what we say is ensure index, and we pass it one single parameter, which is actually a JavaScript object, as is normally the format with these Mongo methods. Now within this JavaScript object, we're going to pass in a single key value pair with age, which is a field that we want to query on, and just a 1 after there. So if I run this now, we can see that it says it's successfully created the index. Now you can see here number of indexes after, there's 2. So there was 1 before we ran it, and now there's 2. So you may be asking, what is this other index? So we will take a look what this other index is. If we go back and we can say db.customers.get indexes, this will show us all of the indexes that are currently against the customers collection. If we run this, you can see there's 2 indexes. This is an array here, and each of the objects, each of the 2 objects in here represent an index. You can see here's the one we added for age. You can see you've got a key value pair here which shows us it is the age field that we are running that we have implemented. And here is the name. It created a name for us of age_1, but we already had this index in place already on the ID field, the underscore ID field, which is the primary key as we spoke about in previous videos, and the name is underscore ID underscore. So MongoDB, whenever you create a new collection, it will implement this index for you on the ID field. So now that we have our index in place on the age field, we're going to rerun our query, and we're going to chain our explain method again with to fetch our execution stats, and we'll run this, and we'll go down to the key line again. Here we are. Total docs examined now is 1. Again, because we had the index in place, Mongo knew exactly where to go to find the documents that had the customer document that had an age of greater than 70. Rather than looking through all 11 documents, it just went straight to the particular record required, which was our friend Jack Nicholson with the age of 75. So you couldn't see how much quicker the query ran this time versus when it didn't have an index in place. But just by looking at the stats, we can see how many less documents the Mongo had to look through, and you can just imagine that if there was 2 million records, it would have been very, very much faster with the index in place. So just to show you one other thing about if we want to remove an index, in a very similar format, we would go to drop index, and again we have the parameter that we pass is the JavaScript object. A JavaScript object will always contain a key value pair. The key is the field of the index you want to, the field which contains the index that you wish to drop, and then the 1 afterwards. So if I run this, we can see that our index has been successfully removed. And if we go back and run the get indexes again, we can then see that all we're left with is the underscore ID index. So you may be thinking, okay, so if it's that much faster when you add indexes to a collection, then why don't I just add indexes to all the fields? We have one on ID already, as you saw before, and I added one on age. Let's add to all of them. However, the problem is the more indexes that you add to your collection, the longer it's going to take when you add records. Because when you add records to a collection, it also has to add records to, it also has to update the index. And the same applies to update and delete commands. So whether you are inserting, updating, or deleting your collection, if your collection contains fields that have indexes on them, those indexes are going to need to be updated with each command. So it's very sensible to limit the fields to which you apply indexes only to fields that you often use to search, that you use for search criteria. So let's now look at the same thing on the SQL database side with our MySQL database. We're going to be looking at our customers table as we did on the Mongo side. I'm going to start up a new SQL window. The first command I'm going to run is just to show you that our customers table, I'm just going to do a count to show you that it has the 11 records in there, the same as it did on the Mongo side. And if we just run a select query, we're going to select star from customers, and we run this. You can see here are all of our records, and what we did on the Mongo side is we just did a search criteria where age was greater than 70. So if we run that, we're just left with our Jack Nicholson record. Now, the way to analyze queries in MySQL is very similar to the way we did it on the Mongo side. We're using, again, the explain keyword, but here you're actually prepending explain to the statement. And if we run this now, it will give us the information back similar to what it did with Mongo. And you can see here's the number of rows that it had to look through to find this particular record of the person with an age greater than 70. It had to search through all 11 records in the table. So we want to change that. We don't want it to have to search through all 11 records to find our Jack Nicholson record. So we're going to add our index, and the way I do this is, I'm going to write it in caps, is create index. And unlike with Mongo, where it automatically named the index for me based on the field that I was indexing, I actually have to explicitly write the name of the index I want to create, and I have to say on and give it the table name. Now I want to add my index on customers, and then I add some brackets here and just add the field that I want to put the index on. So if I run this now, that successfully added the index. I run my explain again, and you can see now it is it knows exactly where to find that record in the table because it has an index on the age field, and it can go straight to it. Now, if we want to remove that index, this is a SQL rewrite. We have to prepend with alter table, and then we are going to give the table name, which is customers, and then we're going to write the command drop index. Then in brackets we are going to give the name of the index, which is age 1. Actually, I've just noticed there should not be any brackets around there. And if we run this now, that successfully removed the index. We run our query, our explain query again, on the same query, and you can see we're back to MySQL is back to having to check all 11 rows to pull our Jack Nicholson record. So I hope that gives you a good idea of the benefits of indexing in both SQL and NoSQL databases. I look forward to seeing you in the next lesson.